So now, what is kinetic energy? Kinetic energy is the energy of a body due to its motion. That is what a kinetic energy is. So, for example, we can take the wind is blowing and it is turning the blades of a windmill, or moving water is turning a turbine for generating electricity. All that is considered to be doing work. So, okay, let's take another example. A moving hammer drives a nail into the wood because of its kinetic energy. As I've already said you, the kinetic energy in the axe, the potential energy which is stored in the axe, now it is dropped. That is the kinetic energy. So the potential energy gets converted into kinetic energy. Now this kinetic energy drives the nail into the wood. So now the kinetic energy of a moving body is measured by the amount of work it can do before coming to rest. Kinetic energy is equals to motion. It is due to motion of the body, right? So it is measured by the amount of work it can do before coming to rest. Okay. So kinetic energy is represented by Ke. This is the way we use we denote or represent kinetic energy, denote or represent kinetic energy, where K is kinetic and E is energy, or this way, E and then a small subscript K, EK. So the formula for kinetic energy is Ke is equals to 1 by 2 mv square. This is the formula for kinetic energy, that is 1 by 2 mv square. This kinetic energy of a body is directly proportional to the mass of the body. As you can see, kinetic energy is directly proportional to the mass of the body, and it is also directly proportional to the square of the velocity, square of the speed of the body. So if the mass of a body is doubled, that is, if we take 2m, Ke, an object has double the mass, then its kinetic energy is also doubled. And if this mass is halved, then the kinetic energy is also halved. And if this velocity is doubled, then the kinetic energy becomes 4 times. And if this velocity is half, then the kinetic energy becomes 1 by 4 times, as you see, because of this square. So we can say that doubling the velocity has a greater effect on the kinetic energy of a body than doubling its mass. You know, like if we take 2m, it will be just 2 into m. But if we take 2v square, this will be 2 into v into v, 2 into v into v. Therefore doubling its velocity will be will have greater effect on the body. So now we can conclude that since the kinetic energy of a body depends on the mass and velocity, therefore heavy bodies moving with high velocity have more kinetic energy and they can do more work than slow moving bodies of small masses. So this is the reason why the blacksmith uses a heavier hammer than the one used by a goldsmith. And let's take one more example, daily life example, that there is a car going above the hill. There is a car going above the hill. So while the car is in a straight line, when it is traveling in a straight line, that time the car has uniform speed as like, or when the driver is driving a car on the hill, then he has to increase its speed. He has to increase the speed of the car. Why? The question stands, why? So the reason behind this is, when the car is going upwards, when it is going up, then the car does not have to work only against the air resistance and friction, but it also has gravitational force acting downwards. Gravitational force is acting on it downwards. And this car is going upwards, so it is doing work against the direction of motion. Therefore, the velocity of the car has to be increased to work against gravity. So in the next video, we will see the derivation of kinetic energy. Thank you.